Okay, so now we're going to do a little bit of backwards thinking. So when it says right here, find the missing measurement, what they're going to do is they're going to give us the answer. Yeah, they're just going to give us the answer. But then we got to figure out, how did you get to that answer? That'll be interesting. Okay, let's see what we can come up with. So the first idea is that we're going to have two parts, but one of them we don't know. The area of just a simple box like this would just be the base times the height. Now that I have that, we have the one of these, let's call the 11.1 the base. The height, I don't know, but I know the area. I know what it's supposed to equal. I know that it's supposed to equal 123.2. That's kind of interesting. So that equals 11.1 times something. Now the really cool thing is you could actually solve this backwards. If we just divide both sides by 11.1, you would get whatever that answer is. So let's see, 11.1 times, what would we get to get 123.2? Okay, well I know that 11 times 11 is 121. So we're probably looking at something that's gonna get us close to that. Let's see if we did like 11.1 times 11.2. Well, the 2 would multiply and we'd have 2, 2, 2. Then we'd have 1, 1, 1. And then we'd have 1, 1, 1. That would give me 2, 3, 3. Oh no, wait, that'd be 4. 124.32. So I know that's too big. So 11.2, I just kind of took a guess at something, but it wound up being too big. What does that tell me? Well, if I'm doing like a multiple choice piece, I would pick something smaller than 11.2. But either way, all I had to do was take 123.2, divide it by 11.1, and that gave me my question mark. That's it. Piece of cake. All right, let's look at this one. First, I'm going to redraw it into a box. So if I'm going to go about halfway across this red line, because that's like my height here, I'll go back the other way. So there's my box. And this box here is equal to the triangle. Why? Because in a box like this, if you were to kind of split it down that dotted line, that piece would go there, that piece would go there, and you just kind of cut it apart into pieces. All right, so what would we have then? This 8.2 would really turn into 4.1 because we're splitting it in half. So 4.1 is the height of that box. But the base we don't know. We know that the area of it equals the base times the height. And we know the height is 4.1 and the base we don't know. But we do know the area. They gave us the answer, 35.3 equals 4.1 times something. We don't know what that is though. So how do we figure it out? You just divide by 4.1. So there's a lot of division going on here because you're working your way backwards to see what was the piece that you did multiply by previously. All right, let's do just one or two more here. These are pretty straightforward. Some of them are a little bit harder than others, especially we'll get down to number 16 there. That one's a little bit more challenging. But let's do 13 and then 16, and we'll call this video a wrap. We'll actually, no, then we'll go into triangles. We'll go into triangles after that. Okay, so we'd have this parallelogram, which is the same as a box with the same dimensions, where we don't know how big this is. We don't really care about this piece because it's not one of the two perpendicular pieces. This and this line are perpendicular to each other, but that diagonal doesn't help us with the area calculations. Okay, so 7, let's see, 7 would be right here, and the area is 58.8, so we know that 7 times something equals 58.8 because the area equals the base times the height, and that's 7 times something, and that came out to 58.8 equals 7 times something. This one I'm pretty sure is 8. Let's see, 7 times 8 would be 56, or not 8, something .8, 7.8 maybe? No, it'd have to be 8.8. Oh, wow. No, that's going to be neither of those. But either way, what do? We divide by 7 on both sides, and then we would get whatever the question mark is. So you'd use your calculator, calculate this, and you get an answer. Okay, let's wrap it up with number 16. We'll even start fresh here so we can get down to the page. Number 16. Okay, first, let's do some splitting action, which means we got to redraw this as a box. It's going to be a half box. Triangles and trapezoids are half boxes. So I'm going to cut this all the way over, because if it's going to split on that dotted line there, that means that this triangle is going to go down there, and this trapezoid is going to go down here. So we don't know how much this is, and the height was 6, but now it's 6 divided by 2, which is 3. And this down here is 4.7. And they're telling us that the area is 49.8. So if with this I have area equals, just the base times the height. The height is 3. But let's actually give ourselves a little bit more space here, because the base is 2 numbers added together, and one of them I don't know. It's 4.7 plus something. And they tell us that it's 49.8, so I'd have 49.8. Let's call that something x equals 3 times 4.7 plus x. Well, let's take that back, plus x. This could turn into like a distributive property where we do, like I got to solve an equation here. That would be 12 and 2.1, so 14.1 plus 3x, because I got to multiply to 3 to both pieces, equals 49.8. And from here, then you just do solving and then divide by 3, and you would find x. Now, there is another strategy. You could try and guess what that number would be. For example, if I just divided by 3 to start, and then I could figure out something plus something equals that number. Either way, you're looking for a number that when you add 4.7 to it, and then multiply it by 3, you would get 49.8. Okay, that's it. We're going to get into Pythagorean theorem next about finding missing sides there. Very, very similar.